One of the most concerning aspects of the Air India Flight 171 crash investigation is the severely charred damage to the aft enhanced airborne flight recorder, despite the tail section being largely intact. This is highly unusual for a flight recorder that is designed to be crash survivable. Flight recorders are built to extremely robust standards to withstand high G-forces, penetration, and intense fires over 2000 degrees Fahrenheit for a duration of 60 minutes. The fact that the aft flight recorder was severely damaged, charred, and unreadable while the tail section remained mostly intact suggests an internal and localized intense heat source. While the surrounding surfaces were soot-covered from the carbon-rich combustion environment, the burnt flight recorder casing itself was clean of soot, lacking carbonaceous deposits. This suggests a clean-burning thermal exposure, likely from a metal-fed fire such as magnesium, aluminum alloy. Lithium burns very hot and can consume organic materials, leaving little sooty residue on surfaces directly exposed to the flame, unlike a typical hydrocarbon fire which involves jet fuel or cabin material. This is relevant because if the tail section, where the aft is located, didn't experience the full brunt of the impact or a widespread, prolonged fuel fire, then how was the flight recorder inside it so severely damaged? The forward flight recorder, which was recovered from the crushed and fire-damaged nose section, was successfully downloaded. There is no logical explanation that would support a severely aft flight recorder in this crash event, other than it being damaged prior to the crash. The most plausible cause to the damage aft recorder is a lithium battery thermal event as an initiating factor. A lithium battery thermal event fits perfectly into a scenario in which there is an overall power loss or other systems failures that led to the crash. If the battery fire damaged wiring or components supplying power and data to the full authority digital engine control, the system that uses a digital computer to manage all aspects of the aircraft engine's performance, there would likely be an uncommanded engine shutdown, including a fuel cutoff of both engines. The operational conditions of Flight 171 prior to the crash, which included high weather temperatures, a plane that was carrying the maximum payload weight under those conditions, could easily create a perfect storm scenario in which the environment increased the likelihood and severity of an electrical thermal event involving the high-energy lithium-ion battery component, while also significantly increasing the chance of an engine shutdown.